In a system involving step-up and step-down transformers, it is important to understand the protection requirements for each stage. In this scenario, a 120/208 volts to 480 volts step-up transformer feeds 1200 amps at 480 volts to another transformer, which steps the voltage down to 120/208 volts. The primary side of the first transformer is protected by a 1500 amps disconnect sized at 125% based on Table 450.3 of the National Electrical Code. While this 1500 amps disconnect provides adequate protection for the primary side of the first transformer, it does not extend to the secondary side of the second transformer. Therefore, overcurrent protection is necessary on the secondary side of the second transformer to protect the distribution panel and circuits from overcurrent conditions. This overcurrent protection can be achieved by using appropriately sized circuit breakers in the distribution panel that are designed for the specific load being supplied by the second transformer. Another option is to install fuses in the distribution panel or at the source of the circuit. The specific overcurrent protection devices and their ratings should be selected based on the load requirements and the rating of the second transformer. It's crucial to consult with a qualified electrician to determine the appropriate overcurrent protection devices and their placement, ensuring compliance with relevant electrical codes and safety standards. In addition to overcurrent protection, there are several other measures that can be implemented to enhance the overall protection of the electrical system. Firstly, consider installing ground fault circuit interrupters, GFCIs, on circuits that require protection against ground faults, such as those located in wet or outdoor areas. Secondly, surge protection can be provided by installing surge protectors at the distribution panel or at the point of use. These devices protect against voltage surges that can damage equipment and appliances. Thirdly, lightning protection measures should be implemented to safeguard the system from lightning strikes, especially in areas prone to lightning activity. To summarize, while the 1500 amps disconnect on the primary side of the first transformer provides adequate protection for the side, overcurrent protection is required on the secondary side of the second transformer to protect the distribution panel and circuits. The specific overcurrent protection devices and their ratings should be selected based on the load requirements and the rating of the second transformer. Additionally, consider implementing other protective measures such as ground fault protection, surge protection, and lightning protection to ensure the safety and reliability of the entire electrical system. When determining the appropriate overcurrent protection for the secondary side of the second transformer, it's essential to consider several factors. These include the transformer's secondary voltage and current ratings, the load characteristics connected to the distribution panel, and applicable electrical codes and standards. The overcurrent protection devices should be sized to protect the transformer and the downstream circuits from overloads and short circuits, without causing nuisance tripping under normal operating conditions. Furthermore, the overcurrent protection devices should have an interrupting rating sufficient to handle the available fault current at the point of installation. This ensures that the devices can safely interrupt high current faults without failing or causing damage to the electrical system. In addition to selecting the appropriate overcurrent protection devices, it's also important to ensure that they are properly installed and maintained. This includes verifying the correct wiring connections, tightening all terminals, and periodically inspecting the devices for signs of damage or deterioration. Regular maintenance can help identify and address potential problems before they lead to equipment failures or safety hazards. When it comes to ground fault protection, GFCIs are designed to detect small imbalances in current between the hot and neutral conductors, which can indicate a ground fault condition. When a ground fault is detected, the GFCI quickly interrupts the circuit, preventing electrical shock and minimizing the risk of fire. GFCIs are typically required in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. Surge protection devices, SPDs, are designed to protect against transient voltage surges, which can be caused by lightning strikes, power grid switching, or other electrical disturbances. These surges can damage or destroy sensitive electronic equipment if left unprotected. SPD work by diverting excess voltage away from the protected equipment, providing a safe path for the surge current to flow to ground. SPD are available in various configurations, including whole-house surge protectors that are installed at the main electrical panel and point-of-view surge protectors that are plugged into individual outlets. Lightning protection systems are designed to protect buildings and structures from the damaging effects of lightning strikes. These systems typically consist of lightning rods, grounding conductors, and surge protection devices. Lightning rods are installed on the roof of the building to intercept lightning strikes and provide a preferred path for the lightning current to flow to ground. Grounding conductors connect the lightning rods to a grounding system, which dissipates the lightning current into the earth. Surge protection devices are installed at the electrical panel to protect against voltage surges caused by lightning strikes. When designing and installing electrical protection systems, it's important to consult with qualified electrical engineers and contractors who have experience in this field. They can assess the specific protection needs of the facility and recommend the appropriate protection measures to ensure the safety and reliability of the electrical system. Furthermore, it's important to comply with all applicable electrical codes and standards, such as the National Electrical Code, NEC, and local building codes. These codes provide detailed requirements for the design, installation, and maintenance of electrical systems, helping to ensure that they are safe and reliable. By implementing a comprehensive electrical protection strategy that includes overcurrent protection, ground fault protection, surge protection, and lightning protection, facilities can minimize the risk of electrical hazards and protect their equipment and personnel.